Today, Physical Sciences Inc. will present a novel high-power microwave antenna technology that we are developing for the U.S. Navy. The source-agnostic frequency-excluding or SAFE technology is a high-power antenna that radiates across a wide bandwidth, with the ability to notch the gain profile at select frequencies. Frequency notching enables battlefield use without adversely affecting friendly electronic systems. The antenna will serve as the front end of a high-power microwave, directed energy weapon. This directed energy system will be used for vehicle or vessel stopping and counter unmanned aerial systems. Physical Sciences Inc. is an employee-owned contract research and development small business with over 250 employees. In our 50 years, we have addressed numerous problems for the national defense, energy, and health markets. PSI's Deployable Technologies area provides radio frequency and high-power microwave devices to address electronic threats. The SAFE antenna technology responds to the Joint Forces' need for a wideband, directed energy antenna system that incorporates frequency carve-outs that allows the use of a non-lethal vehicle or vessel stopping weapon without interfering with friendly radio frequency systems. This antenna system will be used to form a short to medium range directed energy weapon system for joint DoD use against vehicle and vessel engine targets or small unmanned aerial systems. The sponsoring organization is JIFCO, the Joint Intermediate Force Capabilities Office. JIFCO's requirements call for a SWaP-C minimized antenna system weighing less than 350 pounds and with an antenna diameter less than 1.5 meters. The antenna will operate between 1 to 3 gigahertz and have adjustable 20 megahertz frequency carve-outs for non-interference operation with DoD comms, navigation, and radar systems. Incumbent directed energy systems typically rely on high peak power, narrowband waveforms. These systems use large and heavy parabolic reflectors and narrowband waveguide transmission lines. Broadband high-power microwave or HPM systems are more effective at disabling electronics because there are more wavelengths available to couple into the target. Therefore, broadband systems will achieve greater ranges than narrowband systems for the same average power output, the latter of which is the main driver of the overall size and weight of directed energy systems. During this program, PSI will develop a compact, arrayable antenna element with 100% fractional bandwidth and 300 kilowatts of peak power handling. PSI will array the antenna element to form an aperture with 20 megawatts of peak power and electronic steering capability. PSI will also incorporate physical gain notching structures on the aperture to reduce gain by greater than 6 decibels across 20 megahertz bandwidths. Organizations with an operational need for this vehicle and vessel stopping antenna system include the Department of Defense, the Department of Homeland Security, and the Department of Justice. During the first year of the Phase 2 effort, PSI successfully prototyped the SAFE antenna, demonstrating matched operation across 1 to 3 gigahertz and with adjustable frequency notches incorporated. During the second year, PSI will build antenna array prototypes and test them with high-power sources. PSI is actively working to pair the SAFE antenna technology with a high-power broadband source, such as a cross-field amplifier or nonlinear transmission line. The SAFE antenna is currently TRL-3. Simulations of the antenna have been validated in a laboratory environment, and the antenna manufacturing process is being refined. To date, PSI demonstrated greater than 100% fractional bandwidth and frequency carve-outs with more than 8 decibel gain reduction. PSI demonstrated our manufacturing approach with low-rate production of multiple prototypes. By the end of the Phase 2 program, the SAFE antenna will be TRL-4 after integration and testing with a high-power source. This testing will demonstrate power handling as well as efficient coupling of the source to the antenna aperture. There are several advantages of the SAFE antenna technology compared to incumbent solutions. Due to the adjustable notching capability of the antenna can be used in any location without interfering with friendly frequency bands and without changing the driving source. Soldiers can readily change the notch locations in the gain profile by mechanically adjusting features on the front of the aperture. The broadband nature and coaxial input of the antenna makes it readily available to be paired with any source that operates within the bandwidth. With a higher probability of effect using broadband waveforms, the safe antenna will disable vehicle and vessel engines from greater ranges with the same average power. For this reason, the safe antenna will lead to directed energy weapon systems with smaller sizes and weight, allowing them to be deployed on more agile platforms. PSI will perform field demonstrations with the safe antenna to aid in transitioning the technology. A wideband test at low power will be used to demonstrate frequency notching and non-interference with collocated friendly electronics. A high-power test with narrowband waveforms will be used to demonstrate antenna power handling and show the system disabling vehicle and vessel engine targets. The increased use of low-cost autonomous systems has led to an urgent need for counter-electronic systems with low collateral effects. The primary opportunities within the Department of Defense for the safe antenna include vehicle and vessel stopping missions and counter-unmanned aerial systems. There are also several relevant missions for domestic U.S. agencies. The DHS requires vessel stopping for port protection and vehicle stopping at border control checkpoints. Both the DOJ and local law enforcement have missions for vehicle stopping for interdiction, as well as protection of high-value assets. PSI will develop the safe antenna technology through GIFCO with the goal of integrating an HPM source with the antenna. During the Phase 3 program, testing against DoD-relevant targets will serve as key marketing data for follow-on programs. We identify counter-unmanned aerial systems as a primary market for transitioning HPM technologies. PSI has substantial in-house manufacturing capability to produce the safe antenna and integrate an HPM source from a partnered supplier. We will also form partnerships with providers of directed energy target ID, detection, and tracking systems. In closing, PSI is committed to transitioning high-power microwave technologies to the warfighter. The use of speed of light, counter-electronic effectors, with deep magazines and low cost per shot, will provide the warfighter a much-needed advantage against the increased prevalence of low-cost autonomous systems, while also mitigating collateral effects. PSI's Deployable Technologies Group specializes in the design and manufacturing of novel HPM antenna and source technologies. Please contact Sean Torres, the primary investigator and business development lead for this technology, with any questions or inquiries. Thank you for your time and consideration.